So this is the first lecture, and here we are just going to look at three things. So if I talk about object-oriented programming, there are three questions we are going to address briefly in this video. First of all, what is the need for a new kind of a programming method? So till now we have studied about procedural languages like C. So we already have certain kind of ways in which we can program. So what is the need for this new kind of a way? And then we look at what actually the object oriented programming is, what does it do, and we'll look at very little minute details of how to use such kind of a programming, and then rest of the lectures will take this forward and discuss this in detail. So let's start. So let's quickly look at this timeline of programming languages. If I put this evolution of all the programming languages on a timeline, here I have a timeline and this is the year 1940. So do you know which language was primarily used for coding in this year 1940? And it was your machine language. Machine language was essentially just the switches which you could turn on and off, and an off switch was represented as 0 and an on one as 1. So the entire machine language was nothing but a series of zeros and ones. So here we worked here with something called the machine language, and it didn't quite much serve our purpose. We have quickly shifted to the other languages by this year of 1950. We look at in 1950s what was this other language used, but before that what was the problem with this machine language which made us shift to another language? And it's very obvious, right? We do not think in terms of zeros and ones. As an example, assume I want to do a very simple calculation using my computer, which is to add two numbers, say 2 plus 3. I want to do a 2 plus 3. So even in today on our calculators, I just write 2 plus 3 and I get my answer 5. But if you wanted to do this same thing using your machine language, what you were required to do was, you should first of all convert this 2 into a binary form, you should convert this 3 into a binary form again, and this plus operator will also be having some binary symbol. I'm just assuming it is the binary symbol for plus, and then I would actually feed this entire string to my computer and it would give me a result which would again I decode back and get my answer 5. So it seemed like this sort of coding, this coding in assembly language, this coding in machine language was not very realistic to how I think about things in my brain. So I do not think in terms of zeros and ones. I just think what is 2 plus 3 and my computer should tell it's 5. So very quickly we shifted from this machine language to another language which was called assembly language. If you have heard of it, assembly language made the things a little bit more realistic on my part. Here if I wanted to add two numbers, I could actually give an instruction called add, and then I could indicate two registers over here. So these are just some CPU registers, and what R1 and R2 are carrying is some numbers. So in this case CPU register R1 carries my number 2 and CPU register R2 carries my number 3. So what this statement would do is actually add the contents of two registers and put them in another register. Probably R1 next will carry 5 and I can read it from the register. But then again we have very quickly shifted from the assembly language as well, because although for an add instruction assembly language seems to be much comfortable to us, but when you move ahead and make your programs a little bit more complicated, the size of your assembly programs becomes very big. As an example, if you have done any coding in C, Python, Java, anywhere, and you want to, the first program we write there is to print this phrase called hello world on our screen. So in Python or C you would just give a statement to your computer which probably says print and as an argument I pass there hello world, and this hello world is then printed on my screen. But if you do the similar thing in assembly language, it will actually carry some 15 lines of code, which again makes it a bit non-realistic on my brain. Hence we quickly shifted from this assembly language to some other languages, and then came some languages of which the young generation or we today just know of the name. Probably not all of us have coded in such languages called COBOL, Fortran or Pascal. Here I would like to pose a question to you. Did you ever wonder what the full form of this COBOL and Fortran was? If not, go back and look it up. COBOL actually means common business oriented language, and Fortran is formula translator, and both of these languages were actually discovered or actually designed to solve a particular kind of problems which were restricted by their domains, probably this one for business and this one for mathematics. Soon later we were looking for a language which could be used by anybody, which is sort of domain independent, and then we came to our language C, which was invented by Dennis Ritchie in the year 1970, and it is very widely used. C sort of remains like the mother of all programming languages, and all our engineers, computer science engineers, they are made to start learning their coding from C. Okay, fine. So we started coding in C, and then in 1980 probably we have another researcher, Strausstrup, which actually came with this new language called C++. So what is the requirement for this C++ now here? Again, elaborating a little bit over here is C is your procedural language, and C++ is an object oriented language. So to see the need of an object oriented language, we should first know what actually is a procedural language and what is an object oriented language. So if we recall some of the programs we have done in C, probably the factorial of a number or finding the Fibonacci series, etc., 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 most of them were actually most of them paid their emphasis to what we call as a computation. We were mostly solving our computational problems using C, and how it worked probably was you had some main function over here which had certain local variables and some global variables, and then you have a lot of other functions in your program. So function is nothing but a procedure. What you were actually doing is you would divide your entire program into certain subprograms, and then you will make all these functions for these subprograms, and these functions would be calling each other in a complex manner to attain your final objective. So this is what is called a procedural language. Where we have your entire problem divided into multiple statements, and then you solve it. Okay, then what is the need of an object oriented programming is? So for doing this, let me pose a question to you. So today we are using your programming languages and coding in almost every real world applications, be it your mobile games, be it your management systems, which could manage anything from a college to a library to an airport, and then we have your GPS services and all these things. So whenever I talk about real world problems, all these things come into my mind. Social networking site is other one. So let's pick one out of these, and let's talk about a banking management system. So this is something which could be required by me in our daily life practice in our real world. So assume I give this question to you and I say that, okay, come on, let's try and code it using C. So how would you go about it? So in C immediately you will probably start, so you can pause this video and try designing a code in C for this, and then come back and hear it further. Okay, so we start designing this problem using C. Probably the first thing that will come in our mind is and assume I'm talking about this system at a very basic level. Very basic level means that not in terms of some stock shares and debentures of the bank. Let's talk about something which is very basic, like we use a bank for withdrawing money and for borrowing money. Let's just look at that part. So if I want to implement it using, see, the first thing which probably comes in my mind is, let me have a global variable which is int amount, which corresponds to all the money which is present in a bank. Then probably I would like to take an array of integer called customer, which probably will be holding all the account numbers of various customers, and then I'll start thinking about how shall I create my withdraw function, which will probably take as input a particular account number or an amount of money and then perform certain operations over here. And similarly I might have a deposit function which again might take some arguments and give something as an output. So this is the way I would approach this problem in a procedure oriented way. But think of, when I talk about a bank, what does first come in your mind? So I have a vision of a bank in my mind. Whenever I think of a bank, probably the image which pops up in my mind is that of a bank which probably is having a lot of money. So instead of a dollar, since we are in India, let me use our new rupee symbol. So this bank is having a lot of money, and then there are customers out there, right? So these are my individual customers which are having some account numbers, and then I might also be having certain employees in this bank, and all these would be communicating with each other in one form or the other. So this picture is easy on my mind as compared to directly jumping in and start thinking about the complex data structures I would need to do it. So this is how we perceive the problems in our object oriented programming. We'll soon and slowly go into the details how to model it like this, but object oriented programming allows us to keep this vision of the problem in our mind and to work with this vision rather than to start thinking about the complex data structures and functions and how to implement them. Let me take another example. So you must have seen this game which I am going to draw over here. I think with this now all of you know that what I have made over here is, it is nothing but a game of Pac-Man. So if you don't know what this game is, you can quickly go it on Google, play it and come back. It's a very simple game. And let's say I want again you to implement this game using a programming language. Then again, if you start thinking in terms of C and a procedural language, you'll have right away to start with the data structures. As an example, you might start thinking that yes, I need a 2D matrix to represent this board over here. Then I need a XY location, which are in nothing but int x and int y, two variables which stores the location of this Pac-Man. Then I need something to store the locations of these ghosts over here, and then I'm probably going to make some functions which sort of account for whether these Pac-Man and ghosts are at the same place or not in this two-dimensional matrix, so on and so forth, which again sort of makes the picture quite complicated for me. In an object-oriented programming, you will just think of this entire problem like there is a board, there is a Pac-Man, there are certain amount of ghosts which have certain states, and all these are going to interact with each other. So instead of taking everything at once like this, I am going to think about the individual components. What does a board look like? What is a Pac-Man? What is a ghost? And I'll write the associated codes, and later on I'll wind all of this into a big picture, which is essentially like putting the pieces of a puzzle together. We'll look at how do we do it. So this entire motivation of having an object-oriented language came because, since like how we see previously, this machine language was not very realistic to us, and then we shifted to assembly language, again our mind doesn't think in terms of an assembly language, so we shifted to your high level languages like C, and now we have seen some problems, if I think about a real world problem, I think about it in terms of certain entities which are communicating with each other rather than in terms of certain data structures which we implement using C. So what this object oriented programming is doing, it is allowing us to think of the problems in a way which is more closer to your real world. And then again, C++ is not only the only object oriented languages, there are more like Python, Java, etc. And today almost every programming language is object oriented. So the basic concept of an object oriented language is you can model any problem in this world, and any means any. You can model any problem in this world as a set of entities which are communicating with each other, which probably says you can pick up anything in this world and that is an entity. I am an entity, you are an entity, YouTube is an entity, the video which is playing is an entity, so on and so forth. And then our world goes on, our world is dynamic because all these entities, they are communicating with each other. You are an entity, I am an entity, and then we are communicating with each other because there is this third entity called YouTube in between which is connecting both of us. So whenever the interaction between these entities occurs, something happens in the world. If it is raining, then cloud is an entity, your road is an entity, and then they are interacting with each other in the terms that your cloud is making your road go wet. If you talk of the solar system, your sun is an entity, your planets are the entities, and they are interacting in the sense that these planets are revolving around the sun. You can see a social networking site, your people there are the entities and they are then communicating with each other. So these are the ways how we see interacting entities in an object oriented language. So let me again make it a little bit clear, the difference between a procedural language and an object oriented language. In procedural language, we have one function called main. So see, your entire program is divided into a sort of computational units. So this is your main function, and then there will be certain other functions. This is the same diagram which I have drawn before. So all these functions are nothing but the operational units which are doing something, and then there is sort of a communication happening between all of these in terms that one function might call the other and other might return some values to it. This is how a procedural language looks like. But if I talk about an object oriented language, in an object oriented language I have entities. Like here, this is me, I am an entity. Here it is you, you are an entity. Here probably is YouTube, which is an entity, and the communication is happening between these entities, and we'll soon look at how this kind of a communication is established in an object oriented language. So when I'm talking about an entity in an object oriented language, an entity has two things associated with it. Like any program has two things associated with it. So one thing is the state and other thing is the behavior. And the states and behaviors are nothing but state refers to some form of data and behavior refers to some sort of functions. So if you are talking about me as an entity, I might be having certain state. So that state can be probably my gender, my age, my degree, my location, so on and so forth. So this is my current state, which tells you certain facts about me which might change over time. And then when we talk about behavior, then I exhibit several forms of behavior, as in I can be teaching in my class, or I can be studying for my next class, or if I am taking a class, I might be angry on my students and I can throw them out of the class. So this is also essentially a behavior which might depend on one of my states. So one of my state can be a mood. So if my mood is bad, I probably throw a student out of the class. So the state and behaviors can be linked as well. So the picture I wanted to convey is an entity has two things, which is a state and a behavior. State is the data, which are the facts associated with an entity, and behavior is the function which that entity does. So if you look at a cloud, so in the case of a cloud, your state can be the amount of water in the cloud or the location of the cloud, and the behavior can be that the cloud is raining, and whether it is raining heavily or it is raining lightly, so on and so forth. If I talk about a bank, so in bank again your state can be the amount of money present in the bank, the number of customers in the bank, the number of employees in the bank. All of these are your states of possible states of your bank. And then there are certain behavior associated with this bank, and these behaviors can be lend money or it can be borrow money, so on and so forth. So this is how we represent the thing of an entity and a. Now this entire concept of entity is represented in an object oriented language using two jargons. So whenever I talk about an entity in an object oriented language, it means either I am talking about a class or an object. So you might be familiar with these terms. So let's try to understand what classes and objects are. Your entire object oriented programming revolves around just these two words, classes and objects. So for doing that, let us do a very small exercise. I have taken this from one of the YouTube videos which was very nice. I'll probably mention its link in the footers. So okay, listen carefully what I am saying, and then I'll ask a question to you. Cut apple, banana, papaya to prepare salad. Orange and sweet lime are acidic. Pomegranate juice is good for health. Almonds, cashew nuts, raisins are dried so they don't perish for a long time. Tomato, cucumber, brinjals, ladyfingers are available at the weekly market. Artificial ripening among mango is common. Watermelon grows under water. Okay, so tell me now, I'm going to write here 4 words. So tell me which out of these did you hear me speaking out. So did I ever spell dry fruit or juice or fruit or vegetable? So when I conducted this exercise live in my class, almost also I had few raises for all these 4. So I have some students who said yes, you pronounce dry fruit, some juice, and I have students which said that yes, you have pronounced fruits and vegetables as well. But in reality, I have not pronounced any of these. I haven't pronounced dry fruit or vegetable. These 3 phrases or words were not there in what I talked. So what have happened is, when I spoke these sentences to you, see, because of the information overload, there were a lot of things I was speaking about, all these different vegetables and fruits. Your brain just quickly organize them into certain classes. So you probably don't remember what all exact statements I made, but what you remember is, yes, she spoke something about some fruits and she spoke something about some vegetables, and similarly for dry fruit and juice. So this is how our mind works. It classifies things. So from there comes this concept of classes in your object oriented language. So what happens is, fruit is your class, and all those different fruits which I spelled out, be it apple, mango, papaya, banana, they are all objects. Let's also try to understand classes with one more example. Assume I want you to make a campus or an institute. How are you going to work around it? So here are you, and I ask you to make a campus or an institute. So you will not directly go to the venue and start laying bricks there. What probably you will first of all do is to take a piece of paper and design how this institute looks like, which is essentially called a blueprint. And then your blueprint might have many things. That could be the number of classrooms in your institute, the number of cafeteria in this institute, the location of various different places, so on and so forth. After you work well on this initial document, then you actually go out and then make a institute in reality. So what is over there is a blueprint, and what is there over it is something which exists in reality, which is your actual institute. So that is what tells me the concepts of classes and objects in your object oriented language. This blueprint of whatever you have prepared over here is called a class, and the thing which is derived from here, which actually has a place in reality in the world, and in terms of programming language we say that the thing which actually occupies your computer memory is what is called an object. And now if I ask 4 of you to make institutes, then 4 of you will make different kinds of institutes. So I'll have one more over here, one more over here, and one more over here. Now please see that all these institutes might not be the same. This one might have 10 classrooms, while this one 8, while this one 9, and this one might have, let's say, 30. Right? So all of these are actually institutes. These will have certain basic features which tells you that yes, I am an institute. If I ask you to build an institute, you will follow this blueprint, but you can make minor changes into all these variables, but you won't go out and build a temple over there, right? So it will follow the basic blueprint of an institute, but all of these will be your different objects which will be having different values. To further elaborate your example of classes and objects, let's take one more example. So assume I want to depict a bank in your object oriented language. So essentially we are going to have a blueprint for a bank first of all, which is a class. So I start with a blueprint for a bank, and I say that for a bank the main things which matter for me are the amount of money which are present in the bank, and maybe the number of customers and the number of employees. And then this bank might borrow money from some people and might lend money to some people. So this is my basic blueprint of a bank. Now when I put this blueprint out there in existence, I can actually create different instances of your bank. I can have an ICICI bank which probably has, let's say, some $200,000, which has some 15,000 customers, although that's a lot more. It's just an example, and which might have, let's say, some 30 employees. Here might be some other bank, let's say HDFC, which will have a different value for money, different number of customers, and different number of employees from ICICI. And similarly I can have a Axis Bank over here. So all these three are your banks which actually exist in the reality, and we call that they are the instantiations of your bank blueprint over here. So this thing which is a blueprint which just exists in your mind is called a class, and all these three are your different objects of this class, object 1, 2 and 3. To make this difference all the more clear, let's think about this in the sense that if in C we have statements like int I equals to 10. So what does this mean, this entire statement? So what is a int over here? We say that int is a data type. It tells you certain things. It tells me that whichever variable I am going to declare integer will have a fixed amount of memory, and there will be fixed certain operations you can do over this integer. So it might say that you can add or subtract two integers, or you can multiply two integers, but probably if I have a string, it will say that string name, it will tell me a different thing. It will tell me again the amount of memory, which will be specified over there, and it might tell me that yes, you can probably add two strings but you cannot multiply them, so on and so forth. So these are your data types, which essentially tells you the property of these variables over here. So if I make it analogous to your classes and objects, a class is a data type. A class is a data type which tells you whatever object, or okay, so a class is a data type and an object is actually a variable similar to int I. So this class over here, which is data type, tells you what will be the memory allocated to this object and what all kind of functions and operations you can do on it. And like how here we have given this value 10 to I, similarly we can give some values to the data which is present in these objects. So I think that the notion of classes and objects is a little bit clear. We'll take it further in our next lecture. So in the next lectures we are going to look at a small code for a class bank account, and then we'll be also looking at what are the benefits of your object oriented programming. So here in this lecture we have seen at one benefit, that is your object oriented programming allows you to model your real life problems better than what a procedure oriented language.